A hard fault can happen before the startup is executed, or when the stack is corrupted, or when the stack pointer is outside of RAM range. If the startup is not executed, the global and static variables are not initialized. A fault handler must not rely on the initialization of global and static variables and must do explicit initialization or avoid using global or static variables at all. If the stack is corrupted, returns from function calls might not work. A fault handler must not call functions. If the stack pointer is outside of RAM range, local variables, function parameters, and core registers cannot be written on the stack, which means that C functions cannot be executed properly. A fault handler must not use local variables on the stack and must validate the stack pointer before reading the stacked core registers. In this demo, a hard fault is generated before the startup is executed. The fault handler uses only core registers and special function registers and doesn't write anything on the stack. If the stack pointer is within RAM range, the stacked core registers are read from the stack. A UART module is initialized and used to transmit the fault registers and stacked core registers. This data can be transmitted using any communication protocol like SPI, I2C, LIN, CAN, and CAN-FD. CAN and CAN-FD require a precise oscillator, and in most cases, the internal oscillator cannot be used. This line will trigger a hard fault. The first bit is set, and the unaligned bit is set. The stack pointer will be preserved while the hard fault handler is executed. The fault report has been transmitted over UART. The first bit is set, the unaligned bit is set, and the stack pointer has been preserved. The fault handler can also be executed if the stack pointer is outside of RAM range. The first bit is set, the imprecise error bit is set, the unaligned bit is set. The fault report has been transmitted again. The first bit is set, the imprecise error bit is set, the unaligned bit is set. A bus fault is also triggered because the CPU is attempting to write the exception frame at an invalid address. The reason why the bus fault is imprecise is that Cortex-M7 uses a write buffer and it cannot precisely determine which instruction and which address caused the bus fault. Because the stack pointer is outside of RAM range, the link register and program counter and the rest of the stacked core registers cannot be determined.